Okay, so I'll repeat that again. So a function is a relation where every input has only one output. So any questions so far on the definition of a function?
No.
Okay. Sorry, did you have a question?
No.
No. Okay, perfect. Okay, so let's look at graphs first. So we're going to start by looking at graphs to determine if they are a function or not. So we're going to compare functions and non-functions. So I'll sketch a couple pictures, a couple graphs. Okay, so if we sketch this graph, this is a function. So the easiest way to test if something is a function is we use what's called the vertical line test. And we're going to write the definition in a minute. But if you draw a vertical line through any x value, as long as it only crosses one time, that proves that each input has only one output. So in this case, if we slide a vertical line, which we can use our pen or pencil, it never crosses the graph more than one time. And so that's why this is a function. Now, if I turn that graph, it is now a non-function, because if I take my pencil or pen or a vertical line and I go through it, if I stop right here, see how it's crossing the graph right here, and right here. So it intersects it 3 times. That means each input doesn't have only one output. This input, let's pick 0 because that's easy. When x is 0, it has 3 different outputs. It has this output, and this output.
So that means for this lesson, you don't need to show work?
Well, you have to explain. So all of them, when it asks you, it's going to have you explain why or why not.
That's what I meant, because when I typed them in, I did that the graphic and I explained it. So would I have to resubmit them?
Possibly. So let's see. Just bear with me. We'll have to see. I don't know, Dakota. I don't remember when I looked at yours.
Okay.
Okay. And then if we have something like this, again, anywhere we have a vertical line, it only crosses one time here. If we move it one time there, one time there, one time there. No matter where we move our vertical line, it only crosses one time. So that means that each x has only one y, or each input has only one output. So that's why that one is a function. Now, if we turn this, now if we draw a vertical line, here, it only crosses once. Here, it only crosses once, but what happens right here? It crosses here, 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 multiple times. So this one x value has a lot of different y values. And so that's why this one is not a function. So we'll write the definition of our vertical line test. So it says if a vertical line intersects the graph more than once, it is not a function. So any questions how to identify a function or a non-function on a graph? No? Okay. So let's move on and look in a table. So we're gonna draw our tables. So this one is gonna be 7 boxes. So 2 by 1, 2, 3, 4, 5, 6, 7. So we have our X, which is our input, and our Y, which is our output. Okay, so how do we look at a table and determine, how do we look at a table and determine if it is a function or not a function? So again, we're gonna be using that definition at the top of the page that tells us that each input has only one output, or each X has only one Y. So the biggest thing is to just look for repeating X's. So we have a 1, 0, 3, 1, 4, 5. Okay, so we have to look at the repeating ones. So we have this one for X, and then we have this one that also has a 1 for X. So it's fine that they can repeat. The X is 1 here and 1 here again. However, they have to have the same Y value in order to be a function. If we look at the Y values though, when X is 1, this time Y was 3, it changed. When X was 1 here, Y was 2. So that tells us that it is not a function, because the input 1 has 2 different outputs. Right? We got 3 one time and we got 2 one time. Any questions on why that table is not a function? Okay. Okay, let's look at this table. So again, what we're really focused on is a repeating X value. So if all of the X values are different, we have -2, -1, 0, 1, 2, 3. None of them repeat. If all of the X values are different, then we know that it is a function. That means that every input has only one output. So the Y's don't matter. The Y's can repeat. They can all be the same like this as long as all of the X's are different. And then it is a function. Okay, so I'll give you a second to finish copying that down, and then let's go ahead and open in your workbook to is it a function? And that's like the 12th page in your notebook under Unit 2. Does anyone need more time to copy down the notes before I switch to the workbook?
Yes, I need more time.
Okay. And so the rest of you go ahead and open up in your packet. I'm gonna go grab my phone and try to get, well, I should have one more student on here today. Remind him. Okay, let's go ahead and switch to the workbook. All right, so we're gonna use those notes we just copied down and determine if these graphs and tables are a function or not a function and explain why. So let's use our vertical line test. So if we have a graph, anywhere we draw a vertical line, so if I draw it here, it can only cross once. So in this case, it only crossed once. In this case, it only crossed once, crossed once, crossed once, and only crossed once. There was only 1 point on each of those lines. So anywhere we draw a vertical line or move our pen through, it only crosses once. So in this case, this is a function. That means that each input has only one output. Any questions on number one?
No.
Okay, number two. So now we're looking at the table. So we have to check using our definition of a function that each input has only one output. So we have 1 and 3, 2 and 5, 3 and 9, 4 and -10, and 5 and 5. So as long as we said none of the x's repeat, then we know it is a function. It's not possible for the input to have different outputs if there's only 1 point at each x. So again, a function, each input has only one output. Let's compare that one with number 3. So it looks pretty similar, but if you look closely, we have a repeating x. The 2, there's another 2, where here there was a 3. So now these are the ones we have to look at, the repeating x's. So it's fine, x can repeat as long as the y's are the same. But since the y's are different, that means the input 2 has 2 different outputs. So it is not a function. Because the input 2 has different outputs. 5 and 9. So one time when x was 2, we got a 5. Another time when x was 2, we got a 9. So that means it's not a function. And then number 4, we're going to have to use our vertical line test. So we can slide our pen through, or you can just draw lines through. So if we draw a line through here, it only crosses once. We draw a line through here, it crosses here and here. So we don't have to go any further. That tells us this is not a function. Because the input -2, so when x is -2, it has an output of 3 and -1. Any questions on this first page?
No.
All right. Flip to the next one. Okay, so we have 4 of you, so we'll each take one, and I'm going to go in alphabetical order. So Cheyenne, you're first. What do you think number 5 is? Do you think number 5 is a function or is not a function?
Not a function.
Very good. And what told you that it's not a function?
Because the 2 dots in
Yep.
the middle of the graph are.
Yep. Excellent. That right there, see how there's 2 points in that vertical line? That's exactly right, Cheyenne. Tells us it's not a function. Each input does not have only one output. Very good. Okay, Dakota, what do you think about number 6?
The function.
It is a function. Very good. Why is it a function, Dakota?
Because the x value does not have the same. It is not doesn't have like the same number over and over again. They have different numbers, 10 points.
Excellent. Right. There's no repeating x's, which tells us then that each input has only one output. Very good. Okay, and then Kaleni, am I pronouncing that correctly?
Yeah.
Okay, what do you think about number 7? Did you say it's a function or a non-function?
It's a non-function.
Good, what told you that?
The repeated x value.
Okay, so if we look at it, it's not just because it repeated the x value. What else about that? So when x was 1, we had 2 different outputs, right? So like if both of them, if it was 1, -4, and then 1, -4, it would be a function as long as the outputs were the same, but in this case, it was different. So very good, you're right, it's not a function. And you're right, because the x repeated, but they had different outputs. So not a function. Oops, the input 1 has 2 different outputs. -4 and 2. Good. And then Solomon, what about for number 8?
It's not a function.
Good. How do you know?
Because if you go down on the line, it's supposed to only have one line passing through each, and it has more than one.
Right. Well, you could pick pretty much anywhere to draw a vertical line, and we see that crosses here, and crosses here. Right, so we'll say not a function. Each input does not have only one output. Very good. Okay, so any questions on this assignment?
No.
Okay, let's flip to the next one. So we won't do the cutting and pasting, but let's just go through and determine if these are functions or not functions. And we'll just kind of explain why without the cutting and pasting. So number one, let's just go in order again. Cheyenne, what do you think about number one? You think it's a function or not a function?
A function?
Right, very good. Anywhere I draw a vertical line, it only crosses one time. Good, so we'll say this is a function. Each input has only one output. Okay, Dakota, what do you think about number two?
It's not a function.
Excellent. Anywhere, pretty much anywhere, we draw a vertical line. Look how many times it crosses. Good. So it's not a function. We'll say some inputs have more than one output. Kaleni, what do you think about number three?
It is not a function.
Very good. This right here tells us that it's not a function, right? When we put in 1, we got 7 one time, and when we put in 1 again, we got 9 the second time. So we know that the input 1 has 2 different outputs. Any questions so far? Okay. Solomon, what about number 4?
It's a function.
Very good. And how do we explain why is it a function?
Because in the input, if it wasn't a function, there would either be a duplicate of 2 numbers.
Right. Very good. So we know then that each input has only one output. Okay, what do you guys think? Does anyone want to volunteer and tell me for number 5 if you think it's a function or not a function?
I'll do it.
Okay. Is that you, Dakota?
Yes.
Awesome. What do you think?
I think, wait, you want to put the places where the dots go?
What's that for number 5?
Yes, you want to put dots.
Oh, okay. Like this?
No, I said, did you want me to tell you if it was a function or did you want me to tell you where the dots go?
Oh, just tell me if it's a function or not.
Oh, okay. No, it's not a function.
Right. So this is a vertical line, right? And it crosses here, 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 and everywhere in between too. So It's not a function. The input has different outputs. What do you guys think about number 6? Function or not a function?
I think it's function. No, not a function. I don't know.
Anyone else?
Function.
If we draw vertical lines, anywhere we draw a vertical line, does it cross more than once?
No.
Nope. So is it a function then, Dakota?
Yes, it's a function.
Yes, it is a function. Very good. That tells us then
Oh.
that each input has only one output.
And then Solomon's computer died.
Oh, okay. So is he going to join with you?
Summary. Says he's good because he knows it. He knows what to do.
But does he have all these assignments already done?
Do you have all assignments already done?
I think so. I think you turned it.
He says he thinks so. He think he already turned them in.
Did he get full credit? Did you get full credit on them, Solomon, though? Check.
She said check if you got. He can't check. His computer's dead.
Okay. Solomon, why don't you just sit with Dakota?
She wants you to sit with me. She wants me to sit with you.
I want to make sure you have these. Okay, and then let's do some of the applying the functions to racers functions. So let's go back. Well, you know what? I'm going to have to print. We're going to do some interpreting functions. Let me print this really quick. Okay, so let's do the interpreting functions, the bike race assignment next. Okay, so I had already written in the one in my workbook. So here's a blank copy for us. So Antonio and Juan are in a 4-mile bike race. The graph below shows the distance of each racer in miles as a function of time. So we have the time here on the x-axis, and we have the distance here in miles on the y-axis. So we're going to be reading this graph. So who wins the race and how do you know? So that's the first question. Well, first let's look at the graph. So Juan, I'm going to do Juan in blue.
Did you want us to answer the question?
Yes, we're gonna go through and answer. And Dakota, I think we already went over this one together. So if you want to take a little break.
Yeah, I was asking if we did this one.
Yes, I did. I know. I remember doing this one with you. So come back in like 10 minutes. And then we'll do the linear. We're going to talk about linear functions and nonlinear functions.
I did that one with you too.
Okay. What about the, do you need help? Did you do the function notation?
That's the one where it's that, let me see, if I have the notes for it, I already did paper. Because me and you went through that, what's it called again?
You're right. I do remember doing the linear and nonlinear functions with you also. Not sure. I don't remember doing function notation with you though.
Function. What's the one that looks like function notation?
So function notation was like, it would say find f of 2, and then it would say f of x equals 3x plus 5.
Yes, I have that one.
And you did it and you understand it and everything?
Yes, I got help with another teacher with that one.
Okay, perfect. Then you're all set for functions. So just, yeah, just make sure all of those assignments are uploaded then, and then you're good to go.
Okay, thank you.
Okay, thanks, Dakota. Okay, so let's see. Let's just kind of look at the lines and see what's happening. So we can kind of look at 3 minutes. Juan is our blue line. So he is not nearly, he's only about halfway. He's only gone about half a mile, while Antonio, our red line, is already at the 1 mile mark. So Antonio, we can see, starts the race off much faster than Juan. Okay, Juan starts off a little bit slower, but then kind of here at the like 5 minute mark, so that's the 5 minute mark. We see that Antonio kind of maybe tired himself out at the very beginning, and he kind of slows down quite a bit here, and then picks up the pace a little bit at the end, while Juan, right here at about 5 minutes, he picks up the pace. See how his line gets steeper, and he ends up reaching the 4 miles before Antonio. So who wins the race? Well, the blue line got to the 4 first. So that tells us that Juan won the race. And how do you know? He reached 4 miles first. It only took him, if we look down, he made it in 13 minutes, while Antonio didn't get there until it took him 15 minutes. You guys have any questions about reading this graph? No? Okay. Then they want us to complete this table. So we'll just do the 0, we'll do 0, 3, 6, 9, 12, 15. For the x's or the input. And then we'll go through. So Juan, he's my blue line. So I'm going to look at the blue line at 3. He's only at about, oh, let's start at 0. At 0, they're both at 0. So at 0 minutes, they were at 0 at the starting line. At 3 minutes, Juan has gone about half a mile. Antonio, our red line, has gone almost 1 mile, pretty much 1 mile it looks like. At 6 minutes, let's do Juan is our blue line. Juan is at about 1.5 miles, while Antonio is at 2 miles. You guys have any questions about how I'm getting the outputs? Okay, and then at 9 minutes, Juan is at about 2.75, while Antonio is only at about 2.5. And then at 12 minutes, Antonio is did I do something wrong at 9? Let's see. At 9, Antonio, oh, sorry. Antonio's only at about 2.25. Because at 12, he's at about 2.75. And at 15, he's already at 4. Now, Antonio at 12, he's at about 2.75. And at 15, he's at 4. Okay, then C tells us to describe the race during the first 5 minutes. What is happening during the time from the start of the race until the 5-minute mark? So we kind of talked about that at the beginning. Here's the 5-minute mark. So Antonio, see how his line's steeper? That means he started off much faster. So the steeper the line, the faster they're going. So while Juan, he starts off slower. So the first 5 minutes, we'll say Antonio is winning the race. He is going much faster. Than Juan. Any questions on the first page? Okay. D says, imagine you were watching the race and had to announce it over the radio. Write a story describing the race. So we can start off with, well, both here together so we can see. So we would say, you know, Antonio starts off really fast, reaching 1 mile after 3 minutes. And continues increasing his speed. So you'll see even at 3, the line gets steeper. So increasing his speed until minute 5. Then he tired himself out. So Antonio used all his energy in the first 5 minutes of the race, while Juan started off slower. But then passes Antonio after 7 minutes. And wins the race. Beating Antonio by 2 minutes. Any questions about reading and kind of interpreting the graph?
No.
Okay, good. So is Juan's graph a racer's function? Why or why not? So that's just asking, can his graph represent that of a racer? Yes. Is Antonio's graph a racer's function? Yes, because we just went through and explained exactly what happened, and it's totally possible. And then refer back to your work. We don't have to do that, but based on your observations, what is a function? So we already went over this. So a function, it means every input has only one output. Guys have any questions? Okay, you guys ready to compare linear functions and nonlinear functions? So let's go back to our packet. And if you can find the page, so it's just a couple pages after the cutting and pasting one that we didn't cut and paste, but we just did. So the sorting functions and non-functions, just a couple pages behind that, you'll find identifying linear functions. Okay, so if you'll notice, there's a word inside linear functions, and that's line. So a linear function is a straight line. So if it is a straight line, it is a linear function. If it's not a straight line, it is not a linear function. So if we look at number one, is number one a straight line? Yes, it is. So we're going to say it is a linear function. Number two, is number two a linear function? Well, it curves. This is a parabola, so this would be a nonlinear function. Because it curves. Any questions about why something is a linear function or nonlinear function?
No.
Okay, so what do you guys think? Let's see. For number 3, Kaleni, what do you think? Do you think that's a linear function or nonlinear function?
It is a linear function.
You think it is a linear function? So we said if it is a linear function, it's a straight line. So it can't have any curves.
Wait.
So would you classify that as a straight line?
No.
Okay, so then is it a linear function?
It's a non-linear.
Good. We'll say the same thing. It curves, so it's not linear. Cheyenne, what do you think for number 4? Is that a linear function or a nonlinear function?
It is a linear function.
Excellent. It's a line. So it's a linear function because it's a line. All right. Any questions on this page? Nope. Okay, and I'm not going to make you fill out this page because I think we get it. So let's go to this table. So this table kind of puts together everything we've done today. So first we're going to determine if it is a function. So is it a function, meaning does each input have only one output? And then is it a linear function? So is it a straight line? All right, so number 1, let's see, if I draw vertical lines, I don't see anywhere that it crosses more than once. So yes, it is a function. Each input has only one output. Now, is it a linear function? So we said a linear function has to be a straight line. It is not a straight line, so we are going to say no. Why? Because it is not a straight line. Okay, I'll do one more and then I'm going to have you guys help me out. So number 2, is it a function? Well, we use our vertical line test to check. Nowhere does it cross more than once, so yes, it is a function. Each input has only one output. Now, is it a linear function? Yes, it's a straight line. So yes, it is a straight line. Any questions on number 1 and 2? Okay. Cheyenne, what do you think about number 3? Function or not non-function?
Not a function because
Excellent.
it crosses like everywhere.
Right. So if we draw a vertical line here, we see that it crosses twice, right? So we'll say no, some inputs have more than one output. And Cheyenne, what do you think? Is it a linear function?
No, because it's not a straight line.
Right. Very good. Okay, Kaleni, what do you think for number 4? Is number 4 a function?
No, it's not a function
Okay, why not?
because it has more outputs.
So did you draw some vertical lines through it? Where did you see that it crossed more than once?
Wait,
I don't think you can find any, right? Do you want to change your answer?
yeah.
Okay, right. It is a function. So we'd say yes, because each input has only one output. And is it a linear function, Lenny?
Yes,
Yes. How come?
because it has a straight line.
Yep, it's a straight line. Okay, and I'll do the last one because there's only one left. Okay, so is it a function? Let me see. Anywhere I draw a line, I don't see it crossing more than once. So yes, that means each input has only one output. And is it a linear function? It is indeed a straight line. So yes, it is a straight line. Okay, and I do want to do a little bit on the next page because it has the tables. Okay, so we'll just do two on this page. So number 6, is it a function? So we have our x, or inputs, and we have our y's, which are outputs. So if we have 1, 2, 3, and then 5, 7, 9. So is it a function? Yes, there's no repeating x's, like we said. As long as the x's don't repeat, we know it is a function. That means each input has only one output. Now, is it a linear function? Well, we can graph to figure that out. So we have 1, 2, 3, and then we have 5, 7, 9. So we'll say this is 5 and this is 10. So if we graph 1, 5, 2, 7, and 3, 9, that forms a straight line. So yes, is a straight line. And we're going to be getting into this in Unit 3. If you've started, you've seen it, that if there's a constant rate of change, like we're adding 2 each time, then we know it's a linear function. Okay, number 7, is that a function? What do you think, Kalani, for number 7?
Yes.
Yes, very good. And Cheyenne, is this a linear function?
No, because it's not a straight line.
Very good. Okay, are you guys ready to move on? Do you have any questions? No? Okay. So now let's go ahead and move on to function notation. So I do have notes for function notation. So let's go ahead and copy. They're really short notes, but you do have to turn them in. It is an assignment, so we'll go ahead and do it. Okay, so function notation. So function notation is something like this. F of x equals 5x minus 4, and it'll tell you to find f of 2. So all this is saying is now x is 2. And so it wants you to find the value of this function when the input is 2 or the x is 2. So all you do is you're going to plug in the 2 to the x here, and you're going to plug in the 2 for the x here. So our first step is you just plug in the input for the x. So if we're trying to find f of 2, we're going to put 2 in for the x. And that equals 5. But now we know that our input is 2. So we plug in the 2 for that x, and we still subtract 4. Any questions how I plugged in x or plugged in the input? Okay, so then once we do that, we just simplify. So 5 times 2 is 10. We take 10 and we subtract 4. And so f of 2 equals 6. So that tells us for this function, when the input is 2, the output is 6. I'll give you a minute to just finish copying that down, and then we'll turn back to our workbook, to the function notation assignment. Okay. Okay, so just like we saw in our notes, f of x equals negative 4x plus 3. Find f of negative 4. So that means we're just going to plug in negative 4 for this x and for this x. So we're trying to find the output when x is negative 4. So f of negative 4 equals negative 4 times x, though, which is negative 4 plus 3. And then we just simplify. So negative 4 times negative 4 is 16, and 16 plus 3 is 19. So f of negative 4 equals 19. Number 2, we're trying to find f of 3. So we're going to take 3 and plug it in for this x and plug it in for this x. For all of the x's, so f of 3 equals, we plug in 3 for x. Well, x is being squared, so we have to square the 3 and add 1. So 3 squared, that's 3 times 3, which is 9. We add 1. 9 plus 1 is 10, so f of 3 equals 10. So when our input is 3, our output is 10. I'll do one more with you, and then we'll do the next ones together. So f of 9, so we substitute 9 for x, equals x squared. So we know x is 9. We have to square that, plus 3 minus x. So x is 9. So now we just have to simplify. 9 squared is 81. We have plus 3 minus 9. So 81 plus 3 is 84. 84 minus 9 is 75. So f of 9 equals 75. Any questions? Okay, Cheyenne, can you help me do number 4 then?
Okay, so you're going to replace x's with 7.
Very good. Perfect. So then I get 2 times 7, which is 14, and 14 minus 1, which is 13, right?
Yeah. Sorry, my computer just glitched.
Oh, no problem. Very good. Okay, number 5 is a little bit harder, so I'll do that one with you guys. So f of x equals x squared plus 5x. So we have 3 x's here. So we're going to be putting in 10 3 times. So we have f of 10 equals x squared. So we have to do 10 squared plus 5 times x. So 10 squared is 100, and then 5 times 10 is 50. So 100 plus 50, which is 150. So f of 10 equals 150. Okay, Kaleni, can you help me with the number 6?
I'm still trying to figure it out.
Okay, so I'll help you. So f of x, so all they're doing is they plugged in -9 for x. So what we have to do is do the same. So instead of writing x here, we know that x is -9. So we're going to substitute a -9 for this x and any other x we see. So equals negative, and always put your x in parentheses. It's like we've been doing. So x is -9 and then plus 5. And then once you do that, you just have to simplify. So we have a negative times a -9, or a -1 times a -9. So negative times negative, that means it's a positive 9 plus 5, which is 14. So f of -9 equals 14. So all we're doing, yeah, we're just taking the number that they give us and we're just substituting that in for the x's and solving. Number 7, we have f of -3. So that equals -3 squared minus 3. -3 squared, that's -3 times -3, which is +9. 9 minus 3 is 6. So f of -3 equals 6. Okay, Kaleni, can you help me with number 8?
I can try.
Yeah, perfect.
Okay, so you plugged in the -4 for
Good.
the x.
Right, I'm going to plug -4 for all the x's.
And then you simplify the 4 and then
Yep.
-4.
Yep, which is -16 minus 3. Very good.
-19.
Excellent. Yep. And -60 minus 3 is -19. You've got it. So f of -4 equals -19. Okay, let's just do 2 more. Then we have f of x equals x minus 3. So Cheyenne, can you help me with number 9?
So you're going to put -3 into each x's.
Good. Perfect. And then so we have -3 minus 3, which is
-6.
excellent. Very good, Cheyenne. So f of -3 equals -6. And then I'll just go ahead and do the last one. So we have f of 10 equals x squared. So 10 squared minus 5 times x, which is 10. So 10 squared is 100 minus 5 times 10, which is 50. 100 minus 50 is 50. So f of 10 equals 50. All right, you guys have any questions about function notation? No? Okay, so I wanted to save like the last 15 minutes or so to go ahead and take pictures and upload all of these assignments that we just did. So I'm going to open up Canvas and help you guys upload.